Thank you, everyone. So again, I'm Art Swift, president of prpl, and I'm delighted to be here chatting with you. Information security is broken. As an industry, the traditional security approaches are broken, and it should be self-evident by some of the facts and figures that I'll go through here. First of all, the worldwide spending on information security is in excess of $77 billion this year. But yet, every day, every week, we hear about a new data breach, be it the Target data breach, be it all the health records at Anthem stolen, be it Home Depot, or the famous Sony hack that recently occurred. And so just one case, for instance, the Verizon data breach report of 2015, they just released data that said the cost of 700 million stolen records was $400 million. This is just one study by Verizon for their customers in their markets. If you look at worldwide studies of the overall cybercrime market, it's absolutely huge. The estimates are in the order of $700 billion of overall cybercrime. And if you include intellectual property theft via cybercrime and the impacts of that as well, it's in excess of $1 trillion. Now, what's really interesting about it, and this is the reason I asked you the question about updating your routers, 99.9% of the exploits were actually exposed as vulnerabilities previously, but they've never been patched. They're not either because of industry fragmentation or infrastructure problems or difficulty deploying to consumers or businesses. So the vulnerabilities are identified, and there's a great source in case you're interested. It's a CVE database driven in part by the US government that lists by platform, by operating system, by device, the major vulnerabilities that exist. And it ranks them from 1 to 10, 10 being absolutely critical. By the way, there was a critical bug noted just this week for a very large number of wireless routers, which have never been patched, even though this vulnerability was identified. Now, going further, the landscape, the threat landscape is changing. And so traditional approaches are not keeping up with this threat landscape. The reason being is it's no longer a bunch of kids, doing malicious activity. It's not somebody trying to do a drive-by malware attack, infecting the world with some malicious code. These are very targeted attacks. As a matter of fact, 70 to 90% of the malware samples identified are specifically targeted at an individual company. So imagine that. You're being targeted. You as key people in the information technology industry, you could be a specific target for this kind of attack. What's also interesting about the landscape today is that almost everybody is subject to phishing attacks. And phishing attacks meaning you've been specifically targeted because of your business area, and it turns out that 23% of people who are addressed by a phishing attack likely will be compromised because they'll open the phishing messages and they'll then click on the attachments. But to be clear, you may think you're safe by not, well, I never open an attachment. Not so. If you've clicked on a web link, you could easily be compromised as well. Furthermore, if there are images in your email that you've opened, those also could be avenues for a compromise. So finally, all these data breaches you've heard about, Target and Sony and so on, they all involve at some point stolen credentials off a device, like an endpoint, like your laptop, mobile phone, tablet, and so on. And as a matter of fact, this is key to the new emerging threat landscape because the cyber criminals now are much more sophisticated. They actually research very carefully their targets. They identify the specific companies that they're interested in, the specific people. They do the research as to how to address them, and then they actually stage an attack with a specific phishing attempt. The user then clicks on that attack, and their system is compromised. Then the attacker moves laterally through the system, finds the point of attack and the data that they really want, and then they begin to exfiltrate. Let's look at the Target breach, since that's been so well publicized. They targeted a HVAC system. In other words, the air conditioning vendor who manage the HVAC system for Target stores. They compromised the credentials. With that, they were able to move laterally through the network until they were able to attack the point of sale terminals and scrape all the data. So that's just a classic example that's been well publicized. Now, the magnitude of the damage, of course, varies by company and by company size. A recent study showed that big companies, on the average, are experiencing $6 million of direct losses associated with the average data breach. But that's setting aside any damages to reputation, damages to stock price, fines, and so on. So the overall magnitude, if you think about the impact at Sony, for instance, that was devastating to their worldwide credibility. So it has much more far-reaching implications than just these dollar figures. So where does that leave us? Traditional information security is broken. We're spending $77 billion a year to fail to mitigate the threats. It's really, I mean, that's a terrible situation. So the answer is just as Tony King-Smith outlined earlier. It's time for stronger hardware-based security. At the end of the day, we have to design security in from the beginning to our devices at a hardware level to ensure that these kind of threats are mitigated. And it's across multiple domains. So you heard Tony earlier talk about multi-domain security. So it's more than just implementing hardware features across a single domain, in other words, a single use case. It's actually deploying these features across multi-domains and also multi-tenants. And I'll explain what I mean by that in just a moment. So multi-domain and multi-tenant security. Multi-tenants, think about that set-top box example that, or home gateway example that Tony showed earlier. Multiple software services running on an individual device. Then think about the other dimension, the heterogeneous computing aspect. So now you have to run those multiple services across a multi-core architecture that involves multi-core CPUs, GPUs, network processing units, vision systems, and so on. So this is a very complex industry challenge. This is an area where collaboration as an industry is required. And once again, it's not good enough just to have trusted and non-trusted zones. In the future model, it's important to have multiple domains, a true multi-domain and multi-tenant approach. So this strong security model actually beautifully fits how the industry is going with Moore's Law, more and more multi-core scenarios, and of course more heterogeneous computing. As you heard, this is a hypervisor and microkernel-based approach at its, as part of how this is implemented, but it's tied to hardware. So at the end of the day, hardware is managing the key security features. But also, in order to ensure collaboration, we've all got to work together in an open way. So the idea is this is to be an open, secure initiative, open framework such that people can participate, plug in their elements, but also have room to deliver their own solutions. And this reference framework is actually something we're going to be developing through the prpl Foundation. And the OmniShield technology plugs beautifully into this open framework. Now, you might wonder, does anybody want this? Really? So people are pulling for this kind of change? Well, just remember, 77 billion spent in total failure. So recently, one of our member companies, Cup Computing, did a worldwide survey of IT decision makers. And we found that 74% of these CSO or CISO or director of security level people would embrace this kind of hardware-based security approach. Very astonishing. They fully acknowledge that the existing systems are not good enough. Now let's return to that multi-tenant use case just to make sure that everybody understands. This is a real use case. This isn't hypothetical. So for instance, the home gateway that exists in almost all of our houses, supplied by a major carrier, and often here in San Francisco in the Bay Area, there's a number of important carriers. And of course, they're providing base level services to the router. So connection to LTE, connection to DSL, providing the Wi-Fi services and so on. But here in the Bay Area, they're actually doing, in some cases, something else. They're turning your home gateway into a commercial Wi-Fi hotspot, unbeknownst to you. Now, this has been widely publicized, and I won't talk about the specific vendors involved, but think about that. So something that's in your house that you're using to route all your data and connect all your devices to is actually being used as a commercial Wi-Fi hotspot in parallel? What's going on within that? Do you know who's using it? Do you know what they're doing? Are you sure that you're able to isolate what you're doing from what they're doing? And it just gets more complicated because now you map in the ideas of, okay, the utility company wants to buy services from the carrier and put their management services on there, or the carrier wants to offer these kinds of services in order to monitor energy use or IoT or so on. You've also got the pay-per-view streaming application that's completely independent. And obviously you want all of these to be robust and reliable, not interact with each other, not crash each other, and of course keep them secure from one another. But the beautiful thing is you also want to be able to pre-provision the next container, such the next service can be deployed in this kind of application. So any number of additional services could be deployed. Now you may be saying, well, okay, that's just the home gateway use case. A very similar use case applies to automotive. If you just think about it, this is a perfect use case for them because there's new services that are coming into automobiles all the time. You just saw a presentation by the CEO of Altair who shows that virtualization is coming into modems. Interesting. So you're offering multi-domain modem platforms. So this kind of use case is the wave of the future. This is where things are going. But it's very challenging. And that's why we have to get together as an industry to collaborate on it. Now, many of you know me, know that I've been a long-time CPU guy around the industry. I moved into the security field a few years ago. But I've been working on the Intel architecture, the Spark architecture, the MIPS architecture. I've been one of ARM's largest customers. I've launched Alpha. I've worked on every one of them over my long career. And I have to say that my belief is the MIPS architecture is uniquely suited to the challenges here. The reason being is, of course, we all know just from our computer science classes that the MIPS architecture is elegant, simple, it results in small footprints, low power, and so on. But some of the tenets that MIPS has built into their processors over the years are also very important for these security applications. In particular, multi-threading lends itself very nicely to this virtualization-based security model because you're able to, in those multi-tenants, you're able to switch contexts rapidly. In other words, delivering effectively concurrency with very low overhead, so almost zero context switch time. And then the MIPS team has added the hardware support for virtualization in the processors. So at the bottom level, this is all embedded in hardware. Now, traditionally, adding security has taken a bite out of performance. In other words, performance suffers when you add security. But with this approach, really the overhead is very, very low, and that's been the whole goal, so that you can have security without compromising performance. Now, as you heard earlier with the OmniShield announcement, Imagination's IP also fits beautifully across this because they've done the same kinds of things in their GPU and NPU and so on. And basically the premise is that one trusted zone and one untrusted zone is not the model for the future. This is a multi-tenant, multi-domain kind of approach. And it's got to span across a heterogeneous SoC. prpl is the group that's bringing this all together. It's an open source, community-driven effort. The board of directors is a group of industry luminaries, including the director of VP of IoT for Intel, Dan Artuzzi, the CTO of Qualcomm, Matt Grobe, Tony King-Smith, who you know from Imagination, Dan Murata, who runs a multi-billion-dollar business of Broadcom, and myself. As far as who's involved in the security initiatives, SoC makers, IP makers, security specialists, hypervisor people, tools and services, and more are coming. So that's our security working group. And I'd invite you all to engage with us on this industry collaborative effort. So takeaways. Traditional security is broken. People are demanding a hardware-based approach. The existing trusted execution two-domain environment is not going to last the future. It doesn't scale. It doesn't scale across multiple tenants. It doesn't scale in a heterogeneous way. Now, the opportunity for all of you. I would argue that it's security that's the next frontier for all of us. It's no longer low power. It's not mobility. It's really security. You heard it through all the presentations today. You heard people commenting about hacks of aircraft, hacks of cars, hacks of, you name it, space stations were even mentioned. So this is what will drive the next wave of innovation in the IT world. And silicon-level virtualization is a key element of that security paradigm for the future. And as I said, the MIPS architecture and Imaginations IP are really ideally suited for this kind of approach. With that, do I have a minute for questions? Or? Thank you.